Welcome to Raw History. Here, we cut through romanticization and speculation to show you, well, the unfiltered reality of human history. The internet just loves stories about lost ancient technologies that supposedly solve modern problems. Claims about Viking floor hacks using geothermal energy and sophisticated passive heating systems make for compelling videos, but honestly, they distort what Vikings actually built. The archaeological evidence reveals something different, practical construction techniques that used available materials and basic physics to create, marginally better insulation in brutally cold climates. Understanding what Vikings truly accomplished matters more than romanticizing non-existent technologies because, well, their real innovations demonstrate genuine ingenuity within actual constraints. Viking pit houses, known as Grubenhus, did exist throughout Scandinavia during the Viking Age. A pit house is a half-buried structure about 1 meter deep in the ground. It was often only 3 to 4 meters long and 2 to 3 meters wide. Because the excavated earth formed the lower part of the walls, the house naturally benefited from the insulating properties and, to some extent, the heat of the ground. These semi-subterranean structures had their foundations dug into the ground, with the ground itself forming the lower part of the walls, utilizing the environment for thermal insulation. Since less heat is lost by transmission than is in above-ground structures, less energy is required to maintain stable temperatures inside the structure. The pit houses were placed 0.5 meter below the ground so that the floor lies below ground level. This keeps them cool in summer and warm in winter. Archaeological excavations across Scandinavia reveal that Vikings built different structures for different purposes. The Longhouse served as the primary dwelling, varying in length from 10 to 38 meters on average, and rarely more than 5 meters wide. The Viking house was most often a farm that could accommodate between 30 and 50 people, the whole family and its slaves, working, eating, and sleeping under the same roof. Domestic animals were sheltered in a room at one end, providing an additional source of heat. Peat proved the oldest and most common building material naturally insulating. It was used in Greenland and for 1100 years in Iceland, where the peat construction technique was so important that it has survived to the present day. Archaeological research of remains dating from the colonization of Iceland shows that the same types of peat were used to erect walls until the beginning of the 20th century. The peat was removed by lifting the top layer of the ground or cutting it with a small blade spade. The central hearth provided the primary heating source. The hearth was usually located in the middle of the house, which allowed for an even distribution of heat. Fires for cooking and heating would be lit in the central corridor. Some houses had a central fire pit that served the whole house, while others would have had small individual fires in each room or section. The ashes from the fires would be spread out on the packed dirt floor to absorb moisture and smells. The pit houses served primarily as workshops and storage rather than comfortable heated dwellings. Near the Longhouses, the vestiges discovered by the archaeologists indicate that they were used as weaving or pottery workshops, as in Sædding in Denmark, as a forge, as stables for small livestock, or even as houses for slaves. The simple construction made them, accessible for lower-income households and suitable for various craft activities like weaving and metalworking. These buildings would have been quite well insulated due to their construction technique, and may have been used for storing items that needed to be kept cold. They also would have been easier to build, needing less building material, and may have been used for housing slaves and bondsmen. Some believe that these houses served as bathhouses, or perhaps the northern equivalent of a sweat room heated by fire. The thermal mass principle that the Vikings employed, well, it didn't come from any sophisticated engineering. Instead, it was based on basic material properties. You see, stone, earth, and turf walls would absorb heat during the day from fires and body heat. Then they would release it slowly overnight. This method created some degree of temperature moderation, but, it was nothing like the modern passive house standards we have today. The houses remained quite cold by contemporary standards, so they required constant fire maintenance and, of course, heavy clothing indoors throughout those long winter months. Now let's address some claims about Vikings using geothermal heating or creating self-regulating thermal systems. These claims, quite frankly, have no basis in archaeological evidence. The ground temperature at the depth of pit house floors provides minimal heating benefit. In fact, soil temperature at 1 meter depth in Scandinavia hovers around 5 to 8 degrees Celsius year-round. It offers insulation from extreme cold, but, well, no actual heat source. Vikings, just didn't have the technology to tap into deeper geothermal resources or to create the kind of air circulation systems that would really define genuine passive heating designs. The comparison to modern passive house construction is, honestly, a bit misleading. Contemporary passive houses achieve their impressive heating efficiency through very precise air barriers, controlled ventilation with heat recovery, triple glazed windows, and, well, carefully calculated placement of thermal mass. Viking structures, on the other hand, leaked air constantly, had no windows at all, relied on open fires that, frankly, just pulled cold air through the gaps and managed insulation values that were far below what modern building codes would require. The similarity extends only to using thermal mass and thick walls, principles known to every traditional building culture, not unique Viking innovations. The real achievement lay in adapting available materials to create barely adequate shelter in resource-poor environments. In regions with fewer trees like Greenland and Iceland, they utilized stone and turf to build their homes and relied on driftwood for load-bearing beams. This adaptability in construction methods allowed them to effectively settle in diverse environments. Roofs were often constructed with layers of turf as well, creating a natural green covering that blended the houses seamlessly into the landscape. Stone foundations prevented the lower beams of the wooden house walls from rotting by insulating them from the damp ground. This foundation could sometimes support an interior floor of planks, which, when raised, provided additional insulation while also protecting the house from decay. Over time, construction techniques were refined to allow for better durability. Moisture, which was really the primary factor of wear, was avoided through finishes made of clay and dung. The triangular roofing of Viking houses consisted of 3 layers. First, an inner layer of peat, with the grass turned downwards, then a middle layer of compacted soil, and finally a layer of peat oriented upwards. This provided water resistance and some insulation, but it did require constant maintenance and frequent replacement. The buildings demonstrated practical problem solving with limited materials, not, revolutionary thermal engineering. Understanding what Vikings actually built teaches us far more valuable lessons than just romanticizing non-existent technologies. Their construction methods really show how humans adapt to harsh environments by using whatever resources exist locally. The pit house technique, basically burying structures partially to get some modest insulation benefits, shows up in cold climate cultures all over the world. That's because the physics work at basic levels, not because the Vikings discovered some lost secret. Modern sustainable architecture, can actually learn a lot from Viking resourcefulness, especially in how they used local materials and accepted limitations, rather than constantly fighting against them. However, that doesn't mean Viking buildings were thermally efficient by any meaningful standard. They were, cold, smoky, dark spaces that kept occupants just barely warm enough to survive the winter. Appreciating that reality, honestly, honors the genuine hardship Vikings endured and their practical responses to it, instead of projecting our modern comfort expectations onto an era that really knew nothing of them. Subscribe to Raw History for evidence-based explorations of what historical peoples actually built and accomplished. And please, share your thoughts on separating archaeological facts from internet myths in the comments below.